We're looking at 7.4 today. First of all, we have some vocab words. Scalar. That's a quantity that has magnitude. Good.
Is our final next Monday?
Yeah.
Yes, a week from today.
It's gonna be hard.
It's
Midterm. Not good.
it's 50 multiple choice questions. That's it.
All multiple choice.
Yep. No short answer. So, scalar, and then you have vector. Vector is a quantity that has magnitude and direction. So, the difference would be like if I said something like I was driving 50 miles per hour. That's a scalar quantity, that's just a number. But if I said I was driving 50 miles per hour north, now I've given you a vector. I've given you a quantity, a magnitude, and a direction. Okay, so that's the difference between the two. Scalar value is just a number. But if I give you the number with a direction, now I've given you a vector, okay? So we draw vectors using arrows, okay? So vector OP, it's kind of just the same way that you would name a ray in geometry. So you start with the endpoint, and then you pick any other point along the ray. So this we could call vector OP. Okay, so the magnitude of OP, or how, what's a good word for it's strength, right? We designate that using absolute value bars around whatever vector you're talking about, okay? So we have a fill in the blank here to fill in. Two vectors are equal if and only if they have the same direction and same magnitude.
Which is just the absolute value of the vector.
Well, it would have to be the same direction too. So for example, if I drew a vector representing me driving 50 miles per hour north, and then I drew a vector for someone else driving 50 miles per hour north. Since those are we're going the same speed or magnitude in the same direction, those two vectors would be the same. So I'd literally have two identical arrows. The length of the arrow is important because that indicates your magnitude, how long it is. So, for example, I don't know, I might do something like, if I was driving north at 10 miles per hour, it might look like this. If I was driving north at 50 miles per hour, it should be 5 times the length of that, and will look much bigger. Okay, so the length of your vector is important, as well as its direction. Okay, so what if I want to add two vectors together? So this, literally, I mean, you could think of this whole section like playing pool. If I hit the cue ball and I hit another ball here, and I sent it off this way, what is the resulting force that's left? Okay, so one thing you can do is you can add, we call it tip to tail. So the resulting vector, if I had these two that collided, I'd go from the tip of one, or from the tip to the tail, there would be my resulting vector. So if this is vector A and this is vector B, this resulting one would be A plus B. Uh-huh.
You find the magnitude, right?
Yeah, that would be the sum of two vectors. So if I had
So is A a vector, and A and B are both vectors?
yes.
And AB is a magnitude?
Well, it's a vector of them combined.
Okay. So it's just...
Let's say, here's a great example. Let's say I'm walking, and then someone pushes me,
Okay.
right? The resulting vector, so the direction I go in and the speed that I go in is A plus B. So it'd have it's a new vector that has its own magnitude.
So what's
So-
the magnitude of that?
We're going to find that at you have to do this formula down here. Yeah.
Oh, so we haven't even touched the magnitudes yet.
Right. Magnitude is really just, it's represented by the length of the arrow, but to actually find the number, I have to use the formula that's coming up.
Oh,
All right. So, one method to add two vectors together, tip to tail as we did here, or you can do what's called the parallelogram method. So, say I had my two vectors like this, you can kind of copy them and turn it into a parallelogram, and then the vector is the diagonal. So this is still vector A, this is still vector B, so this one is still A plus B. So see, in these two, A plus B ends up being the same thing. It's the same magnitude, same direction, so it doesn't matter if I do the tip to tail method or parallelogram method.
How do you know where to draw the parallelogram up to?
You're just copying it, so I just copied this one, and then I copied this one over here. So then you just draw it from one diagonal. Does that make sense?
No.
I'm not sure what your question is then. How did I know how to...
Why wouldn't you just draw a parallelogram?
I did. So here's why.
Yeah.
Because I'm trying to figure out how to do A plus B, and I can't do the tip to tail method in this case.
Well, why not?
Because the two tails are joined.
oh, because it doesn't have an arrow right there.
Yeah, see how this one went this way and this way, so I could do the tip of this one to the tail of this one.
See that?
This one I can't do tip to tail because their tails are
Yeah.
stuck together. So here I would do parallelogram method, and I just draw the diagonal.
So the arrow at the corner, like the angle right over the up, yeah, that determines whether you can do tip to tail or not, like if it's an arrow or if they're connected.
Yeah, if your two tails are connected, you're going to have to do parallelogram method. This is, yeah, this actually isn't that important. It's just one way to draw how you add these two together. But the point that you need to see is that A plus B is the same in either one. See how it's the same length and it's going the same direction? Yes. Okay, good.
I do see that.
All right, good. All right, so where are we? Vector addition is commutative, so it doesn't matter in what order I add them as long as I add them all together. Every vector v has an opposite vector, negative v. So, let's see, did I draw any of these on this one? No. So, I don't know. Let's just say, I don't know, for any, like if I go back up here and here's me driving 10 miles per hour north, if I had someone driving 10 miles per hour south, we would just cancel each other out. All right. I actually already mentioned the product of a scalar k and a vector u is k times u. That's me telling you if that's 10 miles per hour and I wanted to show 50 miles per hour, it would be 5 times that length. That's all it is. So if I want to do 5 times a vector, no problem. I just do 5 times the whole thing.
Wait, I'm confused about the negative vector. What does that look like again?
It would just be 2 that cancel each other out.
Oh, they cancel each other out?
Right. So exact opposite directions, same magnitude.
Okay.
All right. So writing vectors, a position vector u is in a position vector. U is a vector with an initial point on the origin and the terminal point at A, comma B. All right, so when we draw a vector, we stick with a coordinate plane, and then I'm going to draw it to some, I don't know, let's say I want the vector to go over here. So it's going to go from the origin to this point. Okay? Doesn't that end point there have a coordinate, x, comma, y?
Yes.
Right? So instead of using x's and y's, we use a's and b's. That's all it really is.
But why don't rays go on forever? They don't have endpoints.
Okay, yes, a ray does, but when we're drawing it as a vector, it's not really a ray. It's just, we just use an arrow to represent. It's confusing because you draw a ray the same way. Yeah. All right. So, all I'd have to do to write the location of this vector, I would just give it whatever. Let's say it's at, oh, I don't know, 5 on the x and 2 on the y. That vector there would be written as, and notice these new, they're not parentheses, they're like these pointy brackets. It would just be 5, 2. So A is really like your x coordinate and B is like your y coordinate.
What do you call those parentheses?
Pointy brackets. I don't know if they have a real name. If they have a real name, I don't know what it is. All right, so now let's talk about how to find the actual magnitude or length of this vector. All right. Does this look kind of familiar?
Yeah. Isn't it
What's it reminding you of?
the distance formula?
Oh, kind of. And the distance formula is really just the,
Or what?
I'm hoping you'll say it. The
It's
distance
way of
formula.
finding
It's the point between A and B.
But what formula is it a version of? Pythagorean theorem.
A squared plus B squared equals C squared.
So if I want to find out the magnitude of this vector, for example, remember I have some value for A, some value for B. So isn't it really like I'm just finding the hypotenuse of this triangle? Do you see that? So if I were to drop this down and make it a triangle, I really just have an A and a B. So wouldn't this be the square root of A squared plus B squared?
Yeah.
Yes. So that's how I find the magnitude of my vector. So if I go back up to this example one that was 5, 2, the magnitude of this vector would just be 29,
29.
right? Because 5 squared plus 2 squared gets me 29.
Sounds about right to me.
All right. Now, what if I need to know the direction of this vector? I need to know this angle. Because it's going to be going some magnitude in some direction.
Law of sines or cosines?
Not quite. How about this right here? I would just use this formula. The tangent of theta is b over a. Right? Opposite over adjacent. Can I solve for theta if I
Is
have
there
A and
law
B?
of tangent?
I don't think there is a law of tangent. So, let's see, do I have one of those okay, yeah, we have one here. So, let's try example 1.
Why do you
Find,
need to know theta again?
that's the direction that your vector's traveling in.
Okay.
All right, so let's try example 1. In order to find the magnitude, let's find that first. It's really just kind of like the Pythagorean theorem, right? So the magnitude of my vector is equal to the square root of a squared plus b squared. So if I fill in all the pieces, that would be
5 plus 16 square root.
And 25 and 16 is what, 41? And that does not simplify, so we'll just leave it as square root of 41.
Okay.
So that's going to be the length of my arrow, my vector. And now I need to know in what direction is it going. So to figure that out,
4 over 5.
tan theta equals b over a. So tan theta, 4 over negative 5. So if I want to solve for theta, I need to hit what on the calculator?
Inverse tan.
Yes. What mode should I be in?
Degrees.
Yes. I get negative 38.7. Negative 38.7 degrees.
What'd you type in? inverse tan
And then
4 over negative 5.
you got it. Here's my screen if you want to see it. And what if I were asked, let's say I was taking a multiple choice test and negative 38.7 degrees was not an option. What's equivalent to that?
Oh, tan negative 4 over 5.
I'm saying what degrees is equivalent to negative 38.7? In other words, does anybody remember the vocab word?
Yes, I do. Co-function?
Oh, you're so close. It's not cofunction, it's
Terminal.
coterminal. What is the coterminal angle for negative 38.7? How do you find it?
360 plus negative.
You just add 360 to this. So that is the same thing as 321.3 degrees.
Hint, hint. Is that coming up on the test?
I don't know, we got our final exam in a week. Coterminal might just show up.
Oh, is that one of those things that might be on the final exam?
I honestly don't remember, but that's probably on there.
Probably should be.
I will
I hope that 90% of the test is on coterminal.
I'll be looking over your final exam in the next couple days, and I'll make sure that
How many days of prep do we have for that?
well, we have to get through 7.4 and 7.5. And so,
The test for this chapter?
yes. So let's look at our schedule real quick. Where are we? Right here. So we already did 7.3. So right now we're doing 7.4.
Oh, wow.
So hopefully we'll be able to finish 7.4 and kind of do 7.5.
Tomorrow.
Yeah, so, and then I told you guys that it was up to you. If you wanted this day as a review for 7, and then test 7, or if you wanted to move the test for chapter 7 here and then have 2 days for final exam review. I mean, studying for chapter 7, I mean, you could do both on this day too. Study for chapter 7 and the final. And then you'll have Friday is definitely just final exam review. And we can study for the final once everybody's done with chapter 7 test. Because it's not that long. Yeah.
I'm not gonna be here on
Oh,
Thursday.
is that your AP test?
Wednesday's AP test.
Oh, golly. Well,
So stay after tomorrow and take it.
the test?
Yeah.
Oh, gosh.
I could do it Friday, like during class,
You can. You'll.
because it's just final review, right?
I mean, you could do it when the seniors leave too. That's fine.
Oh, okay.
So we don't. Yeah, I'm not worried about that.
Okay.
So I guess we'll see at the end of tomorrow. We'll figure out if you want to test Wednesday or Thursday.
I won't be here Wednesday. I won't be here Wednesday because I'm going to be out of school.
Oh, golly.
Why the AP? I don't know when the AP test is.
But I think we're definitely missing one of the classes.
Just kidding, I am going to be here. If that's this Thursday, then I'll be here.
Maybe I'll just have it. Maybe I'll just have it. Whoever wants to take it this day takes it this day. Whoever wants it to take it this day, and I'll just give a different version each day. Because I think I have 2 versions, so it's not a big deal. And we can do it that way. All right. So, any Hoosers.
I'm doing math.
Now, in example 2, we're going to try and go the other way. So let's say all I have, instead of having the A and B pieces, let's say all I have is a magnitude and a direction, and I want to figure out the A and B pieces. All right, that's the horizontal and vertical component that they're talking about. That's really just finding A and B. All right, so how do we go backwards? We're going to use these formulas. Okay, so to find A, I just take the magnitude times the cosine of theta. And then-
have these formulas? Are they on our?
That's a great question. Let's look. Ooh, I don't see them.
Uh-oh.
Yeah, I don't see them. So let me talk with the other trig teachers and see what we want to do. If we want to give them or not. Okay. All right, so let's try and go back the other way. So if I want to find the value of A, I take the magnitude times the cosine of theta. Well, the magnitude is given for me right here. It's just 14.5. And I just need to multiply it by the cosine of theta, which is 220. Okay, that's easy enough. I get negative 11.1.
Oh, brother.
And then I just do the same thing for B, and the formula for B is almost the same. It's just that I use sine instead. So I'll be doing 14.5 times sine of 220. So B is negative 9.3. So that means vector V is at negative 11.1, comma, negative 9.3. I can't say I know much about it.
You ever had to gear up?
That's gyro.
That sounds really good though.
Yes,
Their land.
Okay, everybody try example 3A. It's the same that we just did here. You just have some different numbers.
Start making the sushi.
Yeah, it's just probably.
I only like 2 so far.
Yeah, because that's, you get the strength of it. It's filming the sushi roll.
I'm only getting California roll so far. I'm saving Boston. That's good.
Just the real just on the spell. That's good.
No, that's good. California?
Everybody should be trying example 3A.
Did I help you out? What'd you do? Dude, I got that responsible. I got most. Magnitude is 8. Just that many volts. No. We're trying A, B, and C.
Just A.
Okay, I got
If you feel like doing B and C, that's fine.
I got it. Sure, man.
I used one of those this morning. I couldn't really figure out how to use my phone. I hate using my phone calculator.
Okay. Who isn't gonna waste this knowledge? Knowledge good kid.
I'm not gonna waste it.
Hey.
Okay, so I'm assuming everybody has an answer by now, because all you have to do for A to find the value of A is do 8 times cosine 135.
Easy.
Very easy.
Do that in my head.
Negative 4 root 2. Wait, I'm in degrees.
Good.
You need to be in radians?
No, negative 4. We're in degrees to an
And then B is just 8 times the sine of 135.
So you guys in
It's your calculator is giving you your answer in radical form.
Yeah, but in degrees.
It's the same number, but to get it out of it, if you want, I think, yeah, if you go to mode,
Oh,
just,
you're on classic, I'm on
Math print.
yeah,
hazard and- oh, it's not
Math or
Yeah, I just fixed that for you.
yeah, I think you want classic, and then it will give you
Alright, let's try
decimals.
I can't
Yep.
okay, that's good.
So when I get my values for A and B, this vector, they didn't give it a name. Let's call it B again. I would just write it as negative 5.7, comma, positive 5.7. Did you get the same thing? All right, so easy enough. I assume you could do B and C. It's the same idea. Jump down to example 4.
Explore.
We can read this properties of parallelograms if you want. Remember that in a parallelogram you have a quadrilateral whose opposite sides are parallel. The opposite sides and opposite angles of a parallelogram are equal. Adjacent sides are supplementary. Diagonals bisect each other, but don't necessarily bisect opposite angles. Okay, so let's take a look at this one. Two forces of 32 and 48 newtons act on a point in a plane. First of all, do you even know what newtons are?
Yes.
Oh, good.
I remember it, but I don't know what that is.
It's a unit of measurement of force. Okay, so I have a point. So imagine this is you standing in the hallway, and then two mean kids, one pushes you with a force of 32 newtons in this direction, and then another kid pushes you with a force of 48 newtons in this direction.
That doesn't make any sense.
Why not?
They push you at the same time.
They're both going. No, one
So
person-
the resulting vector is where you're going to go and at what magnitude you would be.
Do they push you at the same time?
Yes.
Okay, that makes
So you're standing there, two kids push you, but this one pushes you harder than this one does. Where do you end up? Well, that's when we get to use our parallelogram method. So if I just turn this into a parallelogram, so if I just copy that side and I copy this side, you are going to go in this direction.
Gotcha.
When you add two vectors together, by the way, this new one is called the resultant. So you'll see that right here, resultant vector. All right, so you're standing there, two dweebs push you, 32 and 48. You go this way. Huh?
Who gets pushed by a dweeb?
I don't know.
You'd be getting pushed.
No.
You're
you're-
a bigger dweeb, you're getting pushed by two dweebs.
So anyway, now we want to figure out, so I can kind of see the direction you going, but I want to know with what magnitude, okay? So here's how we're going to do this. Let's see, what do we need? I'm trying to find this,
Just like me.
right?
Just like me and Jack. Just like me.
Just like me and Noah.
Just like me and Jack and Nolan.
Well, that's not helpful at all.
So would you just do
My stomach is growling.
32 plus 48?
No. Because I need their, actually, I take that back. I'm actually not sure. Sorry. My notes from last year are incomplete on this one. Let me see if I have them in here.
Does anyone have a piece of life?
There's a really nice project that we're not going to get to, and I'm kind of sad about it.
You should give it to the juniors once they leave.
It's homework over the summer.
Yes, you.
When they used to,
They were all
ban those, when they banned those from us, or just when they went on the basketball court and Mr. Cannon, like,
For what?
How he banned it.
You banned them from the
What
school?
were they?
Silly man.
Or it's like assistant principal.
Mr. Cannon Institute.
I saw one about those pencils the other day, it used to come in tubes. that
Is a
just
perfect and
smell.
smell.
There's a root beer one, bro. That used to slap. Root beer ones. The ones that come in the tubes that smell pencils.
Oh, okay.
There's some shit.
All right. We actually get to use the law of cosines again. Hooray! So, yes.
38 plus 48.
Well, okay. If this is 32, well, if this is 48, then so is this one, right? So let's just focus on one of these two triangles. If I'm trying to find the length of this triangle, right, with the law of cosines, I really need this angle right here. Do I know it? Or can I find it?
Find it.
How?
Law of cosines.
So you're gonna find out what's that little angle right there.
76.
So you're gonna divide it by 2.
Is it bisect?
No, it doesn't bisect.
Is it bisect?
No, it's not bisected, but there is something that goes on between this and this.
They add to what
76.
it-
Yes, they're supplementary. So that means this angle right here is 104. Now I can use law of cosines to solve for x. So remember how that works. I'm going to take x squared, and it's equal to b squared plus c squared minus 2 times b times c. Times the cosine of a. So there's all my pieces, and now all I have to do is solve for x.
What's that cosine? What does that say? Cosine what?
104. Do you know where 104 came from?
Yes.
Okay.
I have something needed once, did I?
Don't act like you didn't know.
It did.
Uh-huh.
His glasses look weird. Males? Greater than?
Like the quantity. There is literally all the.
She's talking about. He's
There's
talking about
one
It's
females.
all. No wonder no one does anything. It's all dudes.
There's only 3 girls in this class.
And receiver. Or she doesn't count. She knows how to do all this.
Is a woman.
Do I?
She is our superior.
One woman and 3 girls. I will do anything.
All right.
Look at my charger came apart.
So, ladies, gentlemen, 1 point in the plane gets acted upon with these two forces. It's going to end up going in this direction at a magnitude of 64 newtons. So, not quite equal to these two just straight added together. If I wanted to get the full force of both of them acting together, they'd have to go in the same direction.
Why?
Because then I would, how would I get, I'm not getting the full force of both of them together.
I get it. I just wanted to know.
Oh, okay.
It's nice to ask those questions.
It is. So let's say that 2 people came up behind you and one pushes one shoulder and one pushes the other. Then you're going to get the combined force of both of them.
Yes.
Yes, because they're both pushing in the same direction.
Why do we have to be so violent about
I
this?
don't. That was the only example I could think of that made sense.
There. I'll punch Hayden in both sides of his face.
Oh dear. Okay.
Wait, I'll rub my elbow.
Okay, moving on. Moving on. Vector operations. These are a lot easier than they look. Okay? I know this looks like, oh my gosh, that's a whole bunch of things, but it's really not that bad. Take a look at this.
Like the 4% of the alphabet.
Here's just two vectors that you're adding together. You just add the first numbers together and you add the second numbers together. So if I know the horizontal and the vertical components of each one, I just add the first ones, I add the second ones.
Might not be that
This one here, K times AB, this is like how I was saying before, if I was going 10 miles per hour and then 5 times that, I'm going 50 miles per hour. It's the same thing. So if I want to multiply a vector by something, I just multiply both of those values by whatever K is. Okay? The next line talks about the opposite vectors. So if I have a vector that's going to positive A, comma, positive A2, then the opposite would go in the exact opposite direction. They would both be negative. Okay? If I wanted to subtract two vectors, really what I'm going to do is I'm going to distribute the negative into the C and D vectors, and then I add them. So then I'd really have A minus C and B minus D. Oh, wait. That's a typo. This right here should be a D.
Hold up. That looks like a medium.
Can you change that to a D, everybody? Right here, the very last one there should be B minus D. Okay, so watch how we perform these operations. In example 5, if I want to add these two vectors together, I just add the first numbers together and the second numbers together, and I get a new answer of negative 8.
Plus the second number.
That's it, negative 8, 5. B is saying 1/2 V, so I take the V vector and I multiply it by a negative 1/2. So the answer here would be,
I'm so confused.
what's the matter?
I'm lost.
Do you know where I got?
Negative 14 plus 6 to get negative 8. And then you
Why?
move
Because I'm adding the two
negative
vectors
3
together.
plus 8.
Oh, so it just wants you to do that random stuff?
Well, it's not random. Remember, the first number is your horizontal component, and your second is the vertical. So you're just adding the two horizontal components together and the two vertical components together.
Yes.
So that gets you your new horizontal and vertical component.
Okay, so what would you do for B?
Well, B wants you to do 1/2 times the V vector. So I take the V vector and I just multiply them both by negative 1/2.
So it'd be negative 7 and then 4.
I think it'd be positive 7 and a negative 4.
Got it. I got it now.
And then C, now I want 5 times the U vector, and I want to add that to 2 times the V vector. So 5 times the U vector would be 30, negative 15, and I'm going to add that to 2 times the V, negative 28, 16. So now when I add those two together, remember you're adding, 2 comma 1.
Easy.
That's it.
Got it.
Hooray. Okay, so there's another way to write vectors. Instead of using A's and B's in the pointy brackets, it's using I and J notation. I know. I remember when I took physics in college, it was all IJ notation, and I was used to this one, so it was weird. But anyway, IJ notation, same thing. So, well, it's not the same, but take a look at how they're similar, right? I just stick an I and a J on the end of the A and the B, and I don't have brackets when I'm in IJ notation. So if I wanted to write this one using IJ form, I just write it like this. U would equal, instead of, I just stick the 3 in front, so it'd be 3I plus 4J. Okay, you're with me so far? I'll take that as a yes. Okay, all right.
But why would you change it from I to and J?
It's just different notation, so
What does I
it's,
and J represent? U and B?
they're unit vectors. So if you look up here, I is just a vector that has a length of 1 unit in the horizontal direction.
Okay.
J has 1 unit in the vertical direction. So when I'm writing it in IJ form, I'm taking these vectors and I'm usually multiplying by some scalar quantity.
So what's U?
That's the name of the vector.
U is the name of the vector.
Yeah, I'm just giving it a name. I'm just calling that vector U. It could have been vector V, vector J, vector.
So are these just all different ways
Put
of
them
writing
back
X,
to I.
Y, or A and B?
Yes.
Why not just stick to one?
I wish.
Don't like
I,
to be simple.
you'd think. Okay. Everybody with me so far?
I am.
We're gonna get as far as we can get.
Come on.
Yeah, why not? And then we'll be done.
75?
Wow. No.
Why don't we just start?
We already
We
did
do
that.
that after we leave.
Did you know that my girlfriend just took a test on this type of stuff in recalculating high tops?
Good.
So she explained some stuff to me.
Oh, good.
Did
The
she
law
explain
school
that
side,
to
the law
idiots?
school side.
Hey. Did she explain that?
Do you remember the idiot?
Any Hoosers? Okay, so
You're my friend, don't remember this.
now we're gonna talk about something called the dot product. What in the heck is the dot product?
Does it have a product of a dot?
Well, there's a dot in it. So the dot product of two vectors is a real number, not a vector. So if I take u dot v, that's actually how we say it out loud. This is u dot v. That's how we say it. All you have to do is you multiply the first numbers together and you multiply the second numbers together and then you add that answer. So you get a single number when you do it all out. So what does the dot product do for us? I'll read it right from the book for you. Dot products are used to determine the angle between two vectors, to derive geometric theorems, and to solve physics problems. Okay, so if I wanted to do these two vectors and I want to find their dot product, again, guys, it looks super complicated, but the math is really easy. You're just multiplying the first two numbers together, so that's 10. And then I'm going to multiply the second numbers together, and that's -8. And I just add them together. So, kind of. It's called the inner products because you're only doing the outside and inside part because you don't do the first and last. But yeah, you just multiply the first numbers together and the second numbers together, and then add your answers.
But would there be a different way of writing B so 12? By looking at it, you can just tell 10 minus 10. Because it's 0.
Yeah, so then this one's dot product is just 0.
Okay, I don't know if it was like 0, like no solution or 0.
Oh, yep, your answer is just 0.
So it's kind of like foil.
Yes, as Hayden said 30 seconds ago. Yes.
Maybe if you were listening to me.
Okay.
Kill.
All right. Let's see if we can try example